Hello, in this lecture, we will talk about decibel, or dB. The magnitude of a dimensionless quantity g can be expressed in decibels. For example, g in dB equals to 20 times log base 10 of g. This is a logarithm to the base of 10. If you want to convert the g in dB back to the original g in decimal, you can use the second equation. G is 10 to the power of g in dB over 20. The advantage of dB is to represent a wide range of data so that you have a better understanding. The decibel is important in the impedance graph for filter design, body plot of transfer functions, which will be taught in the later lectures. For example, we define a function y equals to 2 times x, where the variable x varies from 1 to 1 million. You can see this is a wide range of data. However, we don't have many data points. On the left-hand side, we have a linear scale plot of y equals to 2x. The problem in the linear scale is that the plot is so dominated by the largest number. If you look at the small number, you lose the details. If we plot it in the semi-log scale, as shown on the right-hand side, every data point is clearly shown without losing any information. As a conclusion, semi-log scale is a meaningful and better way to show data over a wide range without losing any details. Here are a few examples of magnitude in dB. In the left column, we have actual magnitude in decimal. On the right column, we have magnitude in dB. So this is a one-to-one conversion. For example, if you have 1 in decimal, that equals to 0 dB. 0.01 in decimal equals to minus 40 dB. Square root of 2 equals to about 3 dB. 1000 equals to 60 dB. Please try to memorize this table. When I'm doing a circuit design, I often use mathematical software to calculate decibels, such as MATLAB or Octave, Python, Mascad, and Excel. Converting from magnitude to dB, often called mag to dB. Converting from dB back to magnitude in decimal is often called dB to mag. You can define these two functions in Mascad and Excel so that it can make your job much easier. One of my favorite calculator is Python, and we are using Python control system library in this course. So first, make sure you have this library installed in your PC. After that, you can import the control.MATLAB module as ML, which is a short name for MATLAB. You can see here ml.mag2db of 10 in decimal to dB, which is 20 dB, as shown in the results. Also, you can try different values to get more familiar with this function. If you have internet connection, you can go to Octave Online to use mag to dB and dB to mag functions, which is very helpful. Now let's talk about multiplication and division of two complex numbers in dB. In the following slides, you will understand the benefits of using dB to represent magnitudes. Multiplication of two complex numbers. For example, you have a variable y equals to a times b. If you want to represent y in dB, that simply becomes a in dB plus b in dB. So this is the algebra I will gonna skip, but you can go through this algebra, you will have this conclusion. So let's do an exercise. So we have a in decimal, which is 2. From previous slides, we know that it equals to 6 dB. We have b in decimal equals to 20 dB. So y equals to a times b, which is 20. So now we want to convert 20 in decimal into dB. Based on this equation, that simply become A in dB plus B in dB. There will be 6 plus 20 equals to 26 dB. This is the division of two complex numbers. We have y equals to A over B. If we convert them into dB, y in dB equals to A in dB minus B in dB. So this becomes the minus sign for the division. Now let's do the exercise. A equals to 6 dB as we shown before. B equals to 20 dB. We can find A over B in dB by using the equation 6 minus 20 dB, which is minus 14 dB. Summary. In this lecture, we talk about decibels and how to convert them back and forth using Mac to dB and dB to Mac. We see the benefits of using decibels in multiplications and divisions. As a result, the algebra becomes much easier. Thank you and see you next time.